Oh boy. Boy, this is fun. The sitting here clicking admit. Hey, apologies for the delay. I was having a wonderful conversation with one of the service mesh manufacturers about their super keen interest in SMPS, the service mesh performance specification. So yeah, good. Okay, well, welcome everybody. What are we in the dead heat of summer almost? Got two more weeks before we really hit it pretty hard in Texas in terms of humidity. So just, if you're suffering, know that you're in good company. I guess that's the point.
At least you got aircon.
Yeah. Wait. Say it again. At least you have. Oh, nice. So let me find the meeting minutes. All right. Good. Hey, we're about 5 after. Got quite a few of us on. Let's get rolling. At some point, too, I've talked about this in a number of our. Well, I don't know what to refer to them other than community meetings. There's a number of sort of working group meetings. I think there's a Layer5 meeting every day except Thursday, and 2 on Monday, which is great. And in most of those, people are forced to listen to me take forever to get words out of my mouth, and that's not necessary. That's unnecessary suffering. And I guess what I'm calling for, what I'm saying is, we've tried to restructure the format of one of the meetings to be a bit more of a, not a daily stand-up, it's sort of a weekly update and a set of demonstrations. And so what I'm saying is, hey, I'm looking for other hosts or other folks that want to be a lot more verbal on the calls, kind of help steward the call forward. So think about it if that's you. Your jokes couldn't be any worse. Be sure if you're on the call, pop your name into the attendees list, if you would. Also, we've got some new community members this week, which is really nice. We've got Jose and Harsh, some folks whose name I'm gonna not do well with, but Krishna and Ronald, Tim, Neha, Ruth, and I think, Ruth, are you on the call by chance? If you are, we would love to hear from you just to get introduced to you.
Hello.
Hi, Ruth. Welcome.
Hello. It's evening here, so hello everyone. I'm Ruth. I just joined in today. Okay, yesterday. Yeah, yesterday. Or I joined the Slack channel today. So please, can you add my name to the attendees? I'm trying to edit the document, but I'm having some issues. Yeah, I'm joining on my phone, so I'm having some issues editing.
Oh, sure.
Yeah.
Yeah, absolutely. Ruth.
Thank you.
Yeah, thank you. Very nice to have you, Ruth. And by the way, thanks for contributing already. So very helpful.
I've not really done anything. I had some issues at first. I'm going to look at it later. I'm kind of new to programming and open source. I started in March, so I'm still getting my way around everything. So sometimes I make mistakes and I try to resolve them.
Yeah,
So
yeah.
I hope to contribute more.
Mistakes, yeah. You and me both. I have to say that it's been there's and I don't know if everyone else just as a side note is ever bumps into this, but the notion that GitHub does this has a well, it has this probot that will automate the validation of whether or not you've signed off on a commit. It's kind of nice. Like, hey, it's a lot easier to implement or to require developer certificate of origin on an open source project, I think, than it is to require a CLA, a contributor's license agreement, which tends to be a bit more arduous and sort of I think arduous for both those that are hosting the open source project and those that are contributing. But gosh, if it isn't a hindrance to facilitating contribution when the GitHub UI, the web-based UI, if you're editing Markdown or any other file through the UI, even though you're authenticated to the UI, it doesn't facilitate the sign-off on your commits, which means that, people are confounded and frustrated and confused. And so anyway, it's an open, I'm not sure how many, in this regard, like just on open source sort of in general, there's a group called the To-Do group, which I consider has some quite good perspective and kind of guidance for, it's really, I think, oriented toward companies that want to learn how to do open source and maybe have an open source program office, and sort of how do they do that, and what are all the considerations. And they keep track of a list of feature requests for GitHub, of which I think GitHub tends to pay attention to. And I won't be able to find it now, but that particular challenge that we were just talking about is one of the open issues. So yeah. So total random side note, but point of frustration for me. So I'll put a link to the To-Do group in our meeting minutes in case people are interested. Again, a random note, but I'd considered getting a short book out on how to establish an open source program office, and I thought about posting it up on the To-Do group site. But okay, fair enough. Moving on. Shridhi, are you on? Well, or rather, I should say, Shridhi. I'm working.
Hey, yeah, I'm on.
Okay, good. I'm getting better.
Definitely.
I wonder if you want to talk to the next topic here.
All right. So we have 4 new and exciting blog posts up. The first would be by Kush Trivedi. His post is about his experience with Layer5 through the GSOC internship program. The second would be by Naveen Jan. You can find the links in the community meetings of the posts that I'm talking about. So Naveen Jan talks about SMI conformance testing with Meshri. The third would be by Kaneshkar, who talks about his community bridge internship and his experience with Layer5. The fourth would be another experience post written by Ashish Kumar Singh, which is his account of getting into open source with Layer5. These are all very, very good examples of experience posts and the kind of posts that we want to get out on the Layer5 blog. So if anybody has ideas for any kind of articles on Layer5 or its projects, or any kind of promotion articles, or even just want to get out word about their own work in Layer5 through experience posts, which will also be a very good idea for you as a contributor to open source, as a person, to get your name out there, please contact me or Lee or any community manager, and we will help you get it out. We will help you even write the post if you need that. And we will make sure that it is set up on the Layer5 blog. You can see all the blogs that we are currently working on and will be working on in the future in the content calendar. A link is provided in the meeting notes. So yeah, please do contribute through the articles. This is a great way of promoting Layer5, and we are here to help you.
Nice. There's a link to a content calendar, a simple spreadsheet of activities that are going on in the community. And as a matter of fact, so toss your name in here, or if you have something you think that we should do, this is a good place to kind of track what we think we're doing. Speaking of, there are meetups and podcasts and other things that are going on. Two of which to talk about. So actually last night there was a meetup held in which the guest of honor was Chaim Hellman, who, well, Chaim, you ended up teaching a few folks in Austin how to secure their Mac. Well, how to secure Kubernetes and their mesh, actually. Chaim, I need you. I did get the PDF copy of your slides. We need to get those up on meetup.com.
All right.
Yeah, nice. So Chaim's presentation is a timely example of, well, of doing something together, I guess. Oh, okay, and then next up, Kanishkar, are you on? And if you're not, you will get. Is Kanishkar with us? I don't know that he is. All right, let's keep going. Nuno.
Hello. Is Tinkai connected?
Hi, it's Tingai here.
Oh, okay.
Yeah.
So nice to meet you.
Yeah, nice to meet you.
Okay, so I don't know, Lee, if you want me to go now about K3d kind meshery. Yes. All right.
Yeah, I think it's pretty useful. Yeah, please.
Okay.
Yeah, it will be great.
Let me share the screen. Sorry in advance for icons and everything, you know. Okay, so I think you can see it, right?
Not
yet.
cool. Yeah, now we can
Right?
see your screen.
Okay.
Yeah.
Good. So I'll try to really be brief. So it's 17:17 for me. So let's see if I can do that in 15 minutes. Okay.
Yeah.
So the point here is that Tinkai and me at the very beginning, and actually quite a lot of people have some issues running meshery into inside Windows, running on either WSL or Docker Desktop. If you run Docker Desktop, please only use the Kubernetes from Docker Desktop or any other Kubernetes outside Docker, Micro-K8s, Minikube, name it. The issue is that with or let's say with Docker Desktop, it's not running right now, but with Docker Desktop, what it does is that WSL. Okay, so WSL will have here, so this is a permanent one, but it will have like a Docker Desktop distro running on, where Docker daemon is running on top of it, okay? So whenever you will create a kind or a K3d, for example, cluster, actually it will run only into the Docker Desktop distro. And the problem will come when you will need to have access to the Docker network list, or the Docker network, sorry. And here I'm on Docker on top of my Ubuntu, okay, on WSL. It's version 2 here. You can see it's running, and that's the one I'm using right now. And here, for example, I can see that I did a pre-test before, but I have like the kind Docker network. This one is accessible from my Ubuntu distro, which on Docker desktop, actually all the Docker networks that are kind of created on top of Docker desktop networking, they are not available. I hope it's clear. I know it's kind of difficult for me to explain, but it's how it behaves if you want. So whenever you want to use kind or K3d and use an application on top of it, because it's the point, right? Then it will be blocked. Like you will not be able to access it. That's behind the scenes. That's nothing that we can do right now. Docker is aware. I already kind of told them like several times, but we'll see how it will go forward. Okay.
Hey, Nuno,
right.
if I might interrupt here for just a moment.
Mm-hmm.
I'm going to post a link to a diagram that in the chat here that maybe you could bring up and share.
Oh, yeah.
There was a contributor not too long ago who, now I forget the exact situation, but was having networking challenges between,
Mm-hmm.
the various different layers of indirection. And I guess looking at the picture, they were running Minikube. They were running.
Mm-hmm.
Well,
right,
shoot.
but it's like on Windows or?
I don't recall. I figured that this would help explain things visually, but I don't know.
Yeah. Okay. If you want, is like here the host. Oops. Sorry. Am I editing it? It's not good. Sorry. Anyway, so I'll try not to touch too much. Okay. So the host here will be Docker Desktop. The problem is like when you are in a normal distro, okay, like the one I was in here, whenever I do something, let me just create quickly a K3d actually. E3d V3 Cluster Create. Okay, let me just explain quickly what I'm doing here. I'm passing some cluster init, so don't forget that it's for multi control planes here. And then I'm adding this subject alternative name for the certificate, okay? And this one is my IP that I just did before. So whenever I would do that, okay, here the first part, as you can see, is like create network, and it create K3d K3s default. When I'm on a normal distro, it's actually, let me bring back here, it's actually creating the Docker network, but anything that is like now any application that will use it or try to open a port on this network, the network will be shared with the host, which is the WSL distro here, and this WSL distro here as not this config, so the other config. Okay, I'll show it, but as the, let's say it forwards the ports to the Windows side. Okay, if that makes sense.
Yeah,
so,
yeah, it makes sense.
Okay. So Windows will be able to see the ports open on WSL that were open by K3d applications on top of it, for example. Okay, that's why when I do like I install Arcade just before, but if I do like let me see which context do I have actually. Okay, cool. So if I install Portainer with Arcade, okay, if here we can see that it's using like the node port, and this is the port. Okay, so the node port is simple, is is the Docker node that is created. So it will have a Docker IP right now. So just do that. Portainer will be like creating here. Okay, it's being created, but I don't really care too much. I don't know, my network is quite slow today. But here, the node port, okay, will be actually the node port of my K3d, okay, node. So if I do get nodes, this is my only node, and I think it's I will get the IP. Yeah. Okay. So this will be the IP of the node port. Okay. That's how I will be able to actually access Portainer from WSL itself. However, this IP, so if I ping it from WSL, I can ping it. That's no problem. But now if I go on Windows and I do the same, it doesn't know about this IP, right? Because it's a Docker container on top of WSL. So there's no route to it currently. Okay. So the problem, sorry, 18 minutes already. Come on, no, 8, sorry. Okay, I have 10 more minutes, right? So
Right.
quickly. So all that to explain that when you're running Docker on top of WSL, it works. So kind, K3d, and for the K3d, so now if I do a Maesh CTL start, system start actually, we'll get Maesh again. It's a bit slow, so bear with me just a second. So I have already all the IPs, all good. And here we go. So Maesh now is running on port this one. So I have two things here. This Firefox that I have here is a Firefox running on X window. Okay, so it's a Firefox on top of the WSL itself. So I can reach it, of course, via localhost 981. Okay, so if I just press enter, here we go, right? But the same goes now for Windows, okay? Like I said, thanks to this Docker, so Maesh is on top of Docker, on top of WSL, on top of Windows, okay? That's a lot of tops. But the ports altogether is like forwarded onto the Windows side, okay? So that's the first step. Now, second step, if I'm on Windows, okay, and I do what you did, so I will get my kubeconfig. So here you can see that I'm on the shared WSL dollar. Sorry, for anyone interested, just drop me maybe a message later or tell Lee. We can have maybe a workshop around that. I think that's what Saim wanted to do anyway in August. So it will be kind of very interesting if we can just have time just to explain every step. But here we go. So I'm on the WSL share. I'm on my Ubuntu distro, home, my username, .cube, and here is my config file, okay? So if I will open it, now it will fail. It still checks my context, right? But it will fail. Why? Because if I cat it, you'll see here what I stated just before into the chat. While it's on 0000, okay, and random ports, the problem is like now Maesh is running on top of Docker, okay? So this address doesn't mean anything for the Maesh inside Docker. It doesn't know who is the, let's say, the host hosting it really. So my IP, I think I connected it. So if I just do that, and now I it was one whatever.
So was it 172?
So it will fail. It will fail. It will fail. But you can see all my. Here it goes. It failed. Okay, good. And then I will pass just it. So here, so I know. And the weird, like the copy paste, sometimes it's weird. So here we go. All right. So now, thanks to this famous TLS SAN, this subject alternative name that I set, my server being on 000 or this address, this certificate here is still valid for this address here, okay? So that was the point I was saying to you before. So now, if I redo the same, thanks to the change on the config, sorry, it's a bit slow. Did I save it? Sorry, just a second. It should work, you know, like it's the good IP here. All right, so let me again. Okay, here we go. So now it recognized the IP. See here, server. Now it recognized the IP. So remember, Meshery here, while we are using this address, okay, which is a web address from my Windows machine, the thing is like the application itself is running into the Docker container. So it needed to know where to actually find the host. And now if I go back to Meshery, if I refresh the page, now I have everything here, okay? And I can finally ping my adapters. And again, the adapters were actually already connectable from Meshery to the adapter itself, because now they are using the Docker networking, right? So they are seeing between them. That's not my host here, my own Windows that is pinging this one. Okay, the ping behind the scenes is Meshery pinging his own Docker containers. And are they available? Yes, they are. So now if I go to Linkerd, yeah, Linkerd, it will be good. I keep it like, okay, let me change it. And then if I add the latest version of Linkerd, now it will do something. Okay, so if I go here, last time it was failing, but
yeah, I think it still is.
yeah, that's okay, whatever. Okay, but the point is like, so now back to your initial issue, and that's my 15 minutes actually. I can delete my cluster. Okay, so it's the V3, so it's cluster delete. So it will delete it. And because I deleted it, it doesn't mean that Meshery stops working, and that's the important step now. However, my cluster is no more pingable because now I killed it. So what I did for kind, so back to ThinkEye for your points, right? The thing is like I went to Kubernetes website and I tried to see if they add TLS SAN option. I guess they have, but the other way around, which is really just for ends, reads the doc here, but it's really for local. Okay, so I had to change the 127.0.0.1 to my IP address. Okay, so now if I create cluster with my kind YAML, so the image is pulled, but it was already done. Now it's preparing the nodes and everything. Okay, and it's writing, or it will write the config into the same .cube config file. Okay, so once everything will be up, what I will be able to do here is like, again, go here, delete my previous Kubernetes cluster, add again the config file here. Okay, it's already up, and now you see it's pingable because again it has the correct IP address. So the issue was that the IP address that you add. So when I told you like, can you do this here? So you showed everything, and here you see the server. For you, it was on the local IP. And again, local IP for kind, it means that let's say the Docker kind node here was the one trying to, let's say, Meshery. Where is Meshery? Meshery is like here. Meshery. Where is it? Okay, here, sorry. So this one is loading this file where it states that 127 or 127, like the localhost IP, is the server. So instead of looking on this node here, what it will do is like it will look on its own. Okay, so here on Maesh itself. However, of course, like I said, this is not the IP of the Docker here. However, the port is the important part here because it's is the port that it's used. So by doing here server HTTPS on this port, what it does is like it checks on WSL machine. So where sorry, let me get back to here. Okay, so Minikube. So you have still here something, but like if this is Maesh container, it states like, okay, let me read the config file. The config file states that it's on port 616.443 that is running on the host, and the host knows now. So here it will go like kind of this here, and the host says like, okay, but that's a Docker on another container that is running, and then it forwards the requests, and now they can see each other. But when it was 127 IP, then it could not find it because it would stay here. Does it make sense?
Yes, yes, I can follow along. Yeah.
Good, perfect. I'll stop now.
Cool, thank you. That's very helpful.
Yeah. It really is, Nuno. Nuno, as we consider that webinar or that podcast or whatever we call that, I wonder, and as you go to put a little bit of effort into that, I wonder if maybe Tinkai, between what you've just learned and what Nuno, what you have, if we might update the documentation, the Maesh documentation to.
Yeah, sure thing.
Nice. Okay. Yeah, even when I slapped together that diagram quickly for someone else, I neglected to publish it. Like just that little snafu, a lot of people trip on.
And there's more into like Windows because the ports are mapped only on the local host's IP, so the 127 from WSL. So whenever you need to access from another machine even, then you need to start tunneling everything. That's where inlets or NetSH directly comes into really handy.
Yeah, cool. I probably later on I will write a article or blog to document my experience to troubleshooting this networking issue. And after I write this article, I will can I ask you for a review? Like just have a look at whether I understand it correctly, and yeah, possibly post it on Maesh website.
And I think Nuno, that question's to you.
Yeah, you said lead though, but yeah.
Oh, did you say me? Oh, okay.
No. All good. I'll read
okay.
it. Of course, I'll read it.
Oh, yeah, you can't stop me from reviewing it. I'm going. Yeah, absolutely, Steve. That would be great.
And if I read correctly, sorry, just because I'm back. Like I said, Windows guy annoying is back. So I read into your activities that still the webinar was waiting on you, I guess, or whatever.
Right. Yeah. It's more of it's about me bottlenecking things. It more like I can't. Yeah.
But I mean, there we can do it, right? Or
yeah,
like,
totally. Absolutely. It's a great, yeah. And I think by the point by which we do it, you'll have been like, that'll be your third time presenting it.
That's okay. I still don't have a T-shirt, so sorry. I might not represent correctly Layer5.
Yeah, all right. Let me take a note of that. Matter of fact, we tried to get a couple of T-shirts and some buttons and some books and other things out to Mr. Safter, to Syme, and then the coronavirus got in our way again. The United States Postal Service is not shipping to various places, and so anyway, we've Syme. It's still in a package. It's still all bundled up. So. Good. Well, we've got 20 minutes left. We've got one other topic, another demo today. Naveen and Kanishkar have both been focused on the service mesh interface specification and creating some tooling to verify whether or not a given service mesh's implementation of that specification of SMI is valid or not, works or doesn't work. And they've been designing an architecture in which to perform tests and also to define what tests should be performed. And so with that, I popped a link into our chat that kind of describes high level their project. And then Kanishkar, were you going to try to demo that today?
I can demo it, but yeah, it will be very interesting because like it's all just like shell output for now. I think I'll go about like demoing it and then maybe giving a rough idea of what we did or like how we went about the project. Is that
nice? That sounds great. That sounds great. Why? Provide this context for people really briefly, just because you were talking about the shell output. And that is that there's a community effort to itemize all of the service meshes that are out there, describe them. And one of the things that this landscape does is capture sort of a static state of these 4 different service meshes and whether or not they claim to have implemented against SMI's specification. And I don't, and so part of the output that we're hoping from the tool is to be able to, and when I say claim, I don't mean to put anyone on it. Like the SMI spec itself is quite young. There have been, I think each of these service meshes have achieved the yes mark at one point in time. But as the spec changes and as the service meshes themselves change, inevitably things get slightly out of whack. And so part of what Naveen and Kanishkar are trying to help do is provide easy tooling to verify whether or not a mesh is in sync with the spec. And so anyway, I bring this up, Kanishkar, because part of that, the output that you're going to show today would hopefully be in public-facing reports, but probably more than that would also be in Meshery.
Yeah. So okay, I'll just present. So. So my screen, is it visible? How about the text?
It's pretty good for me. I'm not sure about it on Ruth's mobile phone or not. I'm kidding. Yeah. It's great.
Okay. Yeah. So so we have actually been able to build a test framework kind of setup. So the thing is, we have written a test. We have written the tests for each of the spec. And we've also have some kind of engine which executes these tests on a cluster. So, but now the one place that we are stuck at, or I mean, we haven't worked on yet, is how this would be integrated into Meshery, or I mean, things like that. So for now, it's just code. I mean, it's just a code base that I start. So I run the code which starts the test. So yeah, so this is the test config we're using. So here, like, yeah, so we are using this tool called Cuttle. So Cuttle was initially was designed to allow like testing of, testing of CRDs and things like that. So basically, how it, in simple words, how it works is you have, like, you specify set a YAML file, and Cuttle will apply it, and then after a timeout. So here I've specified the timeout as 120 seconds. So it will run a set of test cases on that applied YAML file. So that's the, like, so this is, we had, so the thing was, we had to modify Cuttle to achieve our use case. So yeah, so we I'll talk about that later. So I guess, yeah, so the tests, so the tests are done. So on the end of a test, you get this JSON response, which corresponds to, like, the test results. So we can see traffic split. It passed these two tests and it failed over here. And actually it errored out on the other test. So we don't see that here. But you can see on traffic access that it passed all the tests, and traffic spec also it passed all the tests. And we can see in the log that it passes on traffic access and traffic spec and traffic split. So actually we were running this conformance test on Maesh, if I'm pronouncing it correctly. So if I do a kubectl get all, sorry for this, but yeah, you can see that Maesh and its corresponding, like, pods and whatever it requires have been deployed. So we are over here, we were we are testing the conformance of Maesh to SMI spec, because I think that is the one that is the closest to achieving it. Like, we are having some issues with traffic split. Traffic split works well on Linkerd, but it doesn't work on Maesh. We're not sure why, but we'll have to figure it out. But yeah, so that's the demo. It's literally just this much that's of interest. Like, this result, ideally what we are supposed to do is, this whole test suite will run as a pod in the cluster, and we would end up, like, maybe through gRPC or something, we start the test. Then after that, once the test is done, this result is sent back to the report is generated, or it's shown on the website, and all that is done. So I think that's all is there for the demo. So that's it for the demo. But yeah, I'll try to, like, I think I and Naveen will try to get a blog post or something in which we describe, like, how we implemented the tool, so that it will, it should describe everything.
Nice. Yeah, part of delivering that was, well, one is to define what should be tested for each spec, right? And then another component to that was to develop a lightweight sample app that you could use. Did you talk about the Learn Layer5 app much?
Oh, no, I realized that. Oh, yeah, so the thing was, we needed a sample app which would help us through this. I mean, the thing is, we needed a sample app that would help us, like, perform tests on it. Like, for example, the sample app that we built, it provides the metrics of the request that it received. So that is helpful, because let's say we want to test traffic access. So what we can do is we deploy our app, and we have two services, service A and B. So now, because each of them have a route called metrics, which and because we build them, like a simple application that just collects metrics. If it receives a request, it collects the details about the request and returns them as metrics. So what happens is, like, we made, let's say service A makes a request to service B. Then what the conformance tool does is, it will make a request from service A to service B, and then see the metrics of service B to see if it received the request from service A, or if the request failed. So based on this, we can write a lot of test cases. Like, let's say that none of the CRDs are deployed. By default, according to the spec, all traffic is blocked. So in that case, we generate a little bit of traffic and see if any of them succeed. If they don't, that means it passed the first test. The next test is to, like, let's say, allow traffic between two services. Then we check, we make requests from service A to service B and see the metrics if it succeeded or failed. If it succeeds, that means that test succeeded. So that's the approach we took to this. And yeah, and yes, so the thing is, we have like modified Cuttle to a decent. I mean, we've taken the project called Cuttle, and we have added a lot of features which would help us do conformance testing. So yeah, I think that summarizes what we did.
Very good. And Kanishkar, you'd begun to articulate that there were a couple of areas where the vanilla Cuttle wasn't going to cut it.
Yeah, actually, Lee, if I haven't pushed the changes to this repo, but if you, it's there in my fork of Cuttle. I'll send you a link of it. I've written it in the README actually. Okay. Like, what are the changes we did? I'll just send you. I'll drop the link in the chat right away. Just a second.
Okay. Yep, and if I recall, I think initially, after having forked Cuttle, the thought was to try to upstream that change, and then I think kind of the further we got along with the modifications that we needed to make, I don't know that upstreaming those is something that that project will want to do, because we needed to build in a bit more logic into the pre-test moment and sort of the post-test moment.
Yeah, actually, I haven't pushed the changes, Lee, so I'll talk about the changes that we did. Is that?
Yeah, sure.
Yeah, yeah. So I think the major change that we needed and did was that Cuttle is, yeah, as I said, it's a declarative testing tool. That means it expects you to write tests in YAML. Now that is easy for like quick tests, but the thing was, as I said, we needed to like make requests and see if the responses were if the request succeeded, or we wanted to see like some specs of SMI, like they're a little more complicated. Like we want to make like multiple requests and see if what is the ratio in which they were split and things like that. So in that case, what we wanted was that we wanted to run custom functions with each test. So let's say we apply a particular YAML file or a particular config in the cluster. We wanted to be able to test it with Go code rather than just YAML files. So this is the first test we did, where we can inject like test handlers or something like that, which would be run after each test, and that function would like perform some tests and then return true or false if the test succeeded or failed. Then the other one was some service meshes require that the namespace in which the application is deployed has some annotations. If it is not annotated, then the service mesh won't inject the sidecar proxy. Now the thing was, Cuttle was handling the namespace creation all by itself. So we did a little bit of tweaking so that we can during the test declaration, like the SMI conformance tool, through that you can specify what namespaces should be set to the namespace that Cuttle will create. Yeah, that's because Cuttle actually, what it does is it creates a random namespace, runs all your tests in it, and deletes the namespace. So we wanted that feature to be able to annotate the namespace which it creates. So that's another change that we did. And other than that, I think these were the main changes. Yeah. Also that it takes Cuttle was designed to be a CLI tool. So because it's, and so what it expects is that you have the kube config file in your system. So Yeah, that's fine. But the thing is, these tests have to be run from inside the cluster as a pod, because these what do you call the conformance tool needs to make requests to some services. So we need to be able and we cannot expose all the services as node ports or load balancers. So we have to run them from inside the cluster. So that'll work only if it was a pod. So what we ended up doing was, instead of we added the feature to be able to pull out the kube config from some environment variables instead of just the kube config YAML. So and I think if you're in a pod, you have two environment variables called Kubernetes service port and Kubernetes service host or something. So these things, so the thing is now using these things, you can get an in-cluster kube config. This is different from what you would get as a CLI, which is running on your machine with your kubectl configured to a particular cluster. So we enable that feature so that it can run as a pod. I think these are the main features that we added. The rest of it, I'll articulate it in the README, I guess. And yeah.
Sure. Yeah, at one point, I think as we were beginning to make that Learn Layer 5 sample app, that it's supposed to fulfill a couple of needs. One, to be a lightweight app to do SMI conformance against. Another one to build some additional workshops around and some service mesh learning around. But I would note that Nick Jackson has this fake service that I had almost considered that we should try to collaborate with him on, because I think it has kind of a similar set of, similar purpose.
Fake service is
fake
crazy good. The guy who wrote it is an absolute genius.
yeah. And so Nick, do you?
One of the most modest people in tech as well.
Yeah. He's one of the tallest people in tech. Nick, I guess briefly, can you introduce this part of the vision for why this was created?
Yeah, so fake service. Literally, I wanted a brute force tool which allowed to be able to do things like testing, routing, load balancing, and reliability, error handling, and things like that without actually creating real code. So fake service is actually a microservice application. It has built-in tracing. It has metrics built in. It can simulate a number of different error conditions. So for example, you can do things like say, I want 55% of all requests to result in an error code, or I want the 95th percentile of all requests to take X milliseconds. And the kind of the reason why I built that into fake service and not using something like Envoy, which does have a certain amount of error injection, is that whilst now Envoy's error injection will allow you to sort of simulate failure situations, I kind of wanted to actually run what was a fake application, but something that I could tune that it looked like a real application. So for example, you have a fake API, and the API has a median request time of 30 milliseconds and a 95th percentile of like 2 seconds. When you're sort of tuning your service mesh and you're actually looking at the operation of your service mesh, you kind of, to play around with the behavior of being able to tune the various different parameters, you really need to have a system which it behaves like a real system, but is tunable to be able to behave consistently. And that's the kind of the key thing, that you can test a real system, but it's very difficult to get the failure state to behave consistently. So with fake service, I basically just bundled all of that and made it tunable so that you can literally just say this particular instance has a 50% failure of every request. This one is 100%. And then that way it'll kind of like it strictly behaves. It supports gRPC and HTTP as well, and there's a bunch of other features in there, such as fake service can actually simulate CPU pressure as well. So you can say that a request consumes 50% of a core, which allows you to sort of simulate the load on a system. It's not a load testing tool, but yeah, I apologize. I can demo this to you all next time if you're all interested. I've got to bounce to another meeting. I'm giving a presentation on Go to some folks out in Brazil, and they don't know what they're getting themselves in for, asking me to do that on a Friday. But so I do apologize, but I've got to go do that now. But I would be more than happy to show you all and next week. It's a super simple tool, but check out the Git repo and complain at me. My docs are probably terrible. I'm bad at that. I'm a bad person. But
got the British spelling on everything too, so that's the
right spelling, Lee.
Yeah,
the right spelling. You'll find I use O's and S's.
Sure.
Thank you. U's and anyway, I do have to run. I'm running late.
Thank you.
Next
See you
time
soon. Yeah.
Have a great weekend.
All right. Thanks, everyone. We'll catch you all next week, I guess. It's the same time. So.
Thank you.
Good to see you all. Thank you for that, Nuno. Thank you, Kanishkar. Great.
Thank you.
Yeah. Bye, guys.
Thank you. Bye.
Bye.
Yeah, bye everyone.